This is the video lesson for 8.3a. Your objective today is generalize that the ratio of corresponding sides of similar shapes are proportional, including a shape and its dilation. So what this means is that we need to have a general idea and be able to show that corresponding sides of similar shapes are proportional. And we could even write those as a ratio. And that includes, similar shapes include a shape and its dilation. So when we dilate a shape, we're actually creating a similar shape that would be proportional to the original shape. So we're going to take some notes here, and I think this is basically a review for you guys. Let's go ahead and take some notes just right here. Give ourselves a little bit of space. Okay. Notes. When we are solving a proportion, or when we're trying to find the missing side of a similar figure, really, step one is to name your ratio. And normally I do small over big, if that works for that problem, but there are lots of ways that we can do it. The whole point of naming our ratio is just to make sure that we're actually following that same setup for the rest of the problem. Step two is to set up your proportion. Okay, and that's always with line equals line. And then step three is to cross multiply and solve. So those are our notes for today. This is a review, but now we're actually applying these similar shapes and the proportional sides to like pictures and word problems and things like that. So we're going to do number 1 and number 2 together. Number 1 says triangle ABC, so ABC, is similar to triangle ADE, ADE. So notice that ADE is actually inside ABC. Find X, the distance from point B to point C. So we're just solving for X. So the first thing we need to do, step 1, is to name our ratio. And I'm going to do this as small over big. My small triangle, ADE, over my big triangle, ABC. So step 2 is to set up your proportion. Line equals line. And if I look at this carefully, I'm going to see that on my small triangle, I have the base and the height. And then on my big triangle, I also have base, but I have to take the base of the whole thing and the height. And height is X here. So let's set this up. Small over big. So I'm going to take 18 feet. That's my small triangle base. And then I need to take my big triangle's base. And it's not just 42 feet. 42 feet is only the distance between here and here. But that wouldn't make a triangle. The base of my large triangle is actually 18 feet plus 42 feet, and whatever that is combined. So what's 18 plus 42? If you put that in your calculator, you're actually going to get 60 feet for that base. So be careful on this. They set it up this way on purpose because they're hoping you're going to use 42 feet, but we need to be smarter than them and use the whole base. So this is small over big. On the other side, I need to do small over big as well. So 12 feet over X. Now before I start cross multiplying, take just a minute to double check and make sure that we have set this up the same way that we named it. Because if we flip-flop something, then our whole answer is going to be wrong right off the bat. So is this small over big? Yep, small over big. Is this small over big? Small over big. So this works. So now we can cross multiply. 18 times x is 18x. 12 times 60, let's put that in our calculator. That's 720. Now I need to divide both sides by 18. I can cancel those out. And if you put this in your calculator, I get x equals 40. And of course, we know that that would be 40 feet. Now remember, whenever we are bubbling in number answers, we have to be very, very careful. First of all, you need to identify that it's positive, and then it's 40 feet. Now I don't want to put my 40 right here, and I don't want to put it over here. I need to keep in mind that 40 has a decimal point at the end, and that's this decimal point right here. So I have to put my 4 and my 0 right there. This is a 4, and this is a 0. On the last test, most of us did this correctly, but a few people bubbled the 4 and the 0 over here. That would be 40 hundredths, or 4/10. That's way less than 1 foot. So we have to be very careful to pay attention to where that decimal point is. Make sure that you're bubbling neatly and completely, because no matter how correct all of this work is, if you don't bubble this right, it's going to be marked wrong, unfortunately. Okay, let's look at number 2 together. There's a good chance you're going to see something like this about shadows and things on your test. So let's look carefully here. The first thing we need to notice is, well, let's go ahead and read the question. Josh is 1.8 meters tall. So this is Josh, and he is 1.8 meters tall. And the way that this copied was not very good, so let's go ahead and write in 1.8 meters. On a sunny day, Lenny measured Josh's shadow and the shadow of their house at the same time. Now this, you can't see it at all, but Josh's shadow here is 1.4 meters. So let's write that in. So we should have 1.8 meters for Josh and 1.4 meters for his shadow. And then the height of his house is x, and the shadow of his house is y. So you can actually picture this as two similar triangles. We have Josh, and we've got his height and his shadow that make a triangle. And then we've got the house. We've got the height of the house and its shadow, which also makes a triangle. So these are two similar triangles. And this is our x, the height, and this is our y, the shadow. So, question A says, if the length of the house's shadow is 5 times the length of Josh's shadow, how long is the house's shadow? Okay, so let's look at that carefully. The length of the house's shadow, that's y. If that's 5 times his shadow, then what's the length of that shadow? So let's go ahead and work that out. Y equals 1.4 times 5. So y equals, let's put that in our calculator. So y equals 7 meters. So now I can say this is 7 meters. Then it's asking us, what is the height of the house? So now I have two things I can do. I'm actually going to work this out two different ways. One way I can do it is to say, well, if the shadow is multiplied by 5, then the height is also going to be multiplied by 5 because it's proportional. That means I have to be doing the same thing to everything. The scale factor here would be 5, so I'd multiply the shadow times 5 and the height times 5. So x equals 1.8 times 5. If I put that in my calculator, 1.8 times 5, I get 9 meters for his height, or for the house's height, sorry. But the more typical way of solving this, let's work it out that way too, would be to set up a proportion. So instead of naming it small over big, actually, you know what, I will. I'll just keep naming it small over big. Small over big. Or I could do Josh over house or something, but I just like kind of looking at the sizes. So now I'm going to set up my proportion. Let's start with our shadows that we know. We know that the small shadow is 1.4 and the large shadow is 7. The small height is 1.8, that's Josh, and then the large height is x, that's the height of the house. And now we can cross multiply. 1.4 times x is 1.4x. 1.8 times 7, that can go in our calculator. That's 12.6. I'm going to divide both sides by 1.4 to get x by itself. So when I divide that, I get 9 meters. So I got the same thing either way. So sometimes it's nice to have different ways of working out math problems. Of course, we want to have this answer easy to find also. So let's jump over to number 7. Jumping over to number 7. The question says the lengths of the sides of two similar triangles are shown below. The shortest side of a similar triangle is 5 centimeters. Okay, and we know that on the big triangle it's 15 centimeters. What are the lengths of the other two sides of the smaller triangle? So we have this side and this side. So I'm going to do one of these with you. So let's go ahead and just kind of divide our space in half here. And let's call this one x, and let's call this one y. So I'm going to do y with you. So let's start by naming our ratio. I'm still going to do small over big, just out of habit. Let's start by setting up our proportion, line equals line. And what we know already is 5 centimeters and 15 centimeters. So I'm definitely using that. That's the only pair of sides that I have. So I'm going to do 5 over 15, small over big. Then I'm looking for y, so that's my small side, and I need to find the corresponding side. Well, it's this one, which is 18. So before we start cross multiplying, let's double check that we've set this up correctly. I've said that I was going to do small over big. 5 is small. 15 is the matching side on the big triangle. Y is small. 18 is the matching side on the big triangle. So we are good to go. Let's cross multiply. 15 times y is 15y. 5 times 18, let's put that in our calculator. That's 90. I'm going to divide both sides by 15. And when we divide that, we get y equals 6 centimeters. Don't forget those units. So now, you need to find x. So please complete all of the steps to find x. Start with naming your ratio, setting up your proportion, and solve, and then bring it to me for your stamp. Please pause now. Now that I've stamped number 7 on your paper, please complete number 4 on your own, and then bring me your paper for another stamp. Let's jump over to number 9 together. Sherry made a scale drawing of her bedroom. Her actual bedroom has a width of 12 feet and a length of 15 feet. The scale drawing of the room has a width of 3 inches. What is the length of the scale drawing? So we need to actually draw a picture here. Let's start by drawing the actual bedroom. Let's say that this is the actual bedroom, and it's 12 feet by 15 feet. And then the scale drawing is here, and it has a width of 3 inches. So let's look here. The width was 12 feet, and here the width is 3 feet, so it has to go right here. So be very careful how you read the problem. Width of 12 feet, width of 3 inches, inches. So those have to be matching sides. And then here, we're looking for the length of the scale drawing. So you know how to set this up. Don't forget, name your ratio, then set up your proportion, and solve. And once you've done that, please bring me your paper for a stamp. So please complete number 9 on your own. Now let's move on to number 10. A museum has scale models representing different time periods in history. A scale in which 1 inch in the model represents 2 feet is used to construct the models. Okay, so this is our scale factor. 1 inch represents 2 feet. So our scale, 1 inch equals 2 feet. That's important. The museum sculptor, the person building these sculptures, wants to build a model of an 18-foot tall tree for one of the museum exhibits. So how tall should he make the model of the tree? So, whenever you are given a scale factor, that's like a present. They're giving us information, and they're really giving us the same information that they're giving in other problems. But the cool thing about being given a scale factor is that they've given us our entire first ratio. So the first thing we need to do is name our ratio, and I'm always going to do that with the units given in the scale. So I'm going to do inches over feet. And now I can set up my proportion, line equals line, and the first ratio is just going to be copied from the scale factor. So this right here is your scale factor. And I'm told that 1 inch, inches goes on top, corresponds to 2 feet on the actual tree. So 2 feet. 1 inch on top, 2 feet on bottom. Now, the other information I'm given is that he wants to build a model of an 18-foot tall tree. Well, feet goes on bottom, so 18 feet goes on bottom. It says how tall should she make the model of the tree. So that's going to be in inches. So what I've done here is I've figured out the scale factor, 1 inch equals 2 feet, and used that as my first ratio. And then inches is what I'm looking for, and I'm given 18 feet. So now I'd like for you to finish solving this proportion, and you definitely know how to do that. You've got lots and lots of practice. When you're finished, please bring me your paper for a stamp on number 10. So now I'll pause the video. I'd like to do part A of number 3 with you, and then let you do B and C on your own. A jeweler created a pin so that the 2 triangles in the pin are similar. So imagine that this is like a little pin that you would pin to your clothes in the shape of a sailboat or whatever this is supposed to be. So write a proportion that could be used to determine x, the length of the larger triangle. Okay, so all we're doing here is writing a proportion. So the first thing we need to do, we're not going to skip the most important part, naming our ratio. I'm going to do small over big. So now I can write a proportion. Line equals line. Let's take our small, so that would be 3 over big, 4.5. So they have to be matching sides. And then our small diagonal is 5 centimeters. And our big diagonal is what we're looking for, x. So now I'd like for you to do B and C on your own. B is just where you're solving for x. C says, what is the ratio between each pair of corresponding sides of these similar triangles? So all that's asking you is, what is the ratio between 3 and 4.5? And what is the ratio between 5 and whatever you figure out for x? What's the ratio? What's the scale factor? That's another way of putting it. What is the scale factor? What do we multiply this triangle by to get the sides on this triangle? When you're finished with number 3, you can bring it to me for a stamp, or you can move straight on to number 8 and get both stamps at once. So you're going to be doing number 3 and number 8. On number 8, I'd like for you to put a neat X through part C. So please complete 3 and 8. Bring me your paper for your stamps, and then at that point I should be able to get your grade to put in the grade book for 8.3